Mathematics crossing your eyes? Maybe Pocket Ronnie can help you.
Alright, we're going to be doing more parabolas, and we're going to be talking about maxima and minima. When you're looking at a parabola, remember a parabola can look like this, and the very bottom is called the vertex. When the parabola is facing up, the very bottom is the vertex, or it's called the minima. It's the minimum point. And there's an xy coordinate for the vertex that they call the minima. When your parabola is facing down, then the very top part is still the vertex, but it's called the maxima. It's the maximum point of the parabola, and that vertex has some xy coordinate as well. In the last lesson, all of our parabolas were symmetrical about the y-axis or the x-axis. When you had this general equation here, this middle term was 0. There was no x term. You only had an x squared term and a whole number. And they were all symmetrical about the y-axis. Now in this lesson, they will not all of them will be symmetrical about the x or the y-axis. So the majority of these problems will have this middle term here. So if we're talking about up and down parabolas, here is the general equation, and remember this coefficient will tell you if it's facing up or down. If that coefficient is positive, it's up. If it's negative, it's down. That coefficient also tells you how wide or narrow the parabola is. This whole number at the end shifts the parabola up or down. If it's a positive number, it shifts up. If it's a negative number, it shifts down. Now we're going to be talking about this middle term. If there is a middle term in your equation, remember parabolas have a where x is squared and y is not. It can also be the reverse, to where y is squared and x is not. Those are right-left parabolas, but when x is squared and y is not, that is an equation of a parabola. So when you have a middle term, you have an x term. This term determines your axis of symmetry. In other words, you will not be symmetrical about the y-axis. Your parabola shifts over to the right or the left. This number tells you if your parabola is shifting up or down. This number will tell you if your parabola is shifting over to the right or the left. So how do you find the new axis of symmetry? Well, there is a formula that you use for the axis of symmetry. You use this formula of x equals negative b over 2a. B and a are the coefficients in front of those terms. So that's where you get b and a are the coefficients. B is the coefficient in front of your x term. A is the coefficient in front of your x squared term. So keep up with your negatives. So when you do this little formula, this will tell you your axis of symmetry. This also tells you your x coordinate of the vertex, which is the maximum or minimum point. Once you have your x coordinate for the vertex, you can then take this value and substitute it back into the original equation to find your y value, which is the y coordinate of your vertex. So let me draw you a picture of what we're talking about. So in the last lesson, your parabolas were symmetrical about the y-axis. They're not going to be symmetrical about the y-axis anymore. We're going to have a new axis of symmetry, and we're going to draw these axes of symmetry with a dotted line. So my parabola, for example, let's just say is symmetrical about this new axis of symmetry, and so my parabola will look like this. And then we are going to find the coordinate, the x and y coordinate of that vertex. For this parabola, that would be called a minima point. It's the minimum of the parabola. If we're talking about right and left parabolas, it's the same concept, except that now our y is a square value and x is not. So all the concepts are the same. Here's the general equation for right and left parabolas. This number here, this coefficient tells you is it facing to the right or the left. If it's positive, it's to the right. If it's negative, it's to the left. That coefficient also tells you how wide or narrow the parabola is. This whole number at the end tells you if it's shifting to the right or to the left. If it's positive, you're shifting to the right. Negative, you're shifting to the left. This term here, if it's not 0, it now will give you a new axis of symmetry. For these parabolas, they were symmetrical about the x-axis. So this number here, this tells you if it's shifting right or left. This tells you if it's shifting up or down. And you have a formula for it too to find the new axis of symmetry. It's the same thing, negative b over 2a. This also tells you the y coordinate of the vertex. Remember, right and left parabolas, they would be like this, and they were symmetrical about the x-axis. But now, when you have a middle term, you're going to be symmetrical about some other axis. Let's just say we're symmetrical about here, and it's going to face to the right. So we'll be able to find this vertex. Using this formula, this will tell you the y coordinate, and then once you have the y coordinate, which is up, then you can take that y value, plug it back into your original equation to find the x value, the x coordinate of that vertex. Okay, we're looking at 25b1. We have this equation. The fact that I have an x squared and y is not squared tells me it's a parabola. Since I have a middle term, I see that I'm not going to be symmetrical about the y-axis, and I have a new axis of symmetry. So in other words, my parabola has been shifted over. It has been shifted up or down, but it's also been shifted over to the right or the left as well. When you have a middle term, that's what it's telling you. So the problem tells us we need to find the axis of symmetry and the vertex for the parabola and then graph it. So to find the axis of symmetry, okay, first off, this coefficient is positive, which tells me I'm smiling. It's positive, I'm smiling, it's facing up. So I go ahead and put that into my head so I can sort of get a simple idea of what it looks like. So to find the new axis of symmetry, you use the formula of x equals negative b over 2a. A and b are these coefficients, just like when we did quadratic formula. Those are the coefficients in front of your x squared term and your x term. So x equals negative, and then my b is negative 4. All over 2 times a, and a is 2. Just the coefficients in front of those terms. So when you have a negative negative, that becomes a positive. So that becomes 4 over 4, which is 1. So basically have x equals 1. That is your new axis of symmetry. You have to remind yourself of how to graph the line x equals 1 on a graph, because this is the line x equals 1. So that is your new axis of symmetry. Then to find, this also represents the x coordinate of your vertex. So since I know this is facing up, then my vertex is a minimum. It's a minimum point. It'll be the lowest point of the parabola. So I already know. So this is your axis of symmetry. Then I know part of my vertex. I know the x coordinate is 1. I need to find the y coordinate. How do I find the y coordinate? I take my x value and I substitute it back into my original equation everywhere I see an x, because y is this, and it will tell me what my y value is. So y equals 2, everywhere I see an x, I'm putting in a 1, minus 4 times 1 plus 1. So y equals 1 squared is 1, 1 times 2 is 2, minus 4 plus 1. Do these in left to right. When you only have addition and subtraction left, you do it from left to right. 2 minus 4 is a negative 2. Negative 2 plus 1 is a negative 1. So my y value is negative 1. So that is my y coordinate. So I now know my y coordinate is negative 1. So I have the vertex. I have my axis of symmetry. I know it's facing up. So I have everything that I need just to sketch a rough draft of the graph. Okay, graphing 25b1, here was our equation. Y equals 2x squared minus 4x plus 1. It's an up and down parabola. The fact that this coefficient is positive tells me it's facing up, it's smiling. So we calculated that our axis of symmetry is 1. How do you graph x equals 1? Everywhere on that line, your x value is going to be 1. So that is a vertical line. Everywhere on that line, your x value will be 1. So you scoot over from the origin 1, and we are going to draw our axis of symmetry with a dashed line. the parabola will now be symmetrical about this new dashed line. So then we can go plot our vertex. Our vertex is at 1, -1. So going over 1 and then down 1, that is our vertex. And we said that the parabola was facing up. And so from this point, I'm okay if you just do a rough sketch. This is a coefficient of 2, which tells you it's going to be a narrower parabola. And so I'm okay if you just do a rough sketch to show that it's going to be facing up from that vertex. That vertex will be, when it's a facing up parabola, that's a minimum point. And they call it a minima point. Okay, we're doing 25b3. I have this equation here. The fact that I have an x squared term and y is not tells me it's a parabola. When x is squared and y is not, that's an up and down parabola. It's not in general form. General form needs to be y on one side and everything else on the other side. So I need to divide everything by 5. So that goes away. So I have y equals -3x squared plus 6x. And there's no number, there's no whole number out there. If you want to write a +0 to let you know that, that's fine. But the fact that there is this middle term tells me I am not symmetrical about the y-axis, that my parabola has been shifted over. And so I need to determine the new axis of symmetry. So we use the formula x equals -b/2a to determine your axis of symmetry. So once you have it in standard form like this is your A, or your general form, B, C. So now I can plug in my values into my formula. X equals B is a +6 all over 2 times, and A is -3. Keep up with your negatives. So that is a -6 over 2 times -3, -6. A negative divided by negative is a positive. 6 divided by 6 is 1, so x equals 1. So that is my axis of symmetry. It also is the coordinate, the x-coordinate of my vertex. So I know that my vertex, the x-coordinate is 1, but I've got to determine my y-coordinate. So how do I determine my y-coordinate? I take this and plug it back in to my equation everywhere I see an x. I'm going to go to this general form equation. You can go back to the original. It's probably better to go back to the original, but I'm going to go right here. So everywhere I see an x, I'm plugging in a 1 so I can figure out my y-coordinate. Because y equals -3 times 1 squared plus 6 times 1, and then I don't need to write +0. 1 squared is 1 times -3 is -3 plus 6. -3 plus 6 is a +3. So therefore my y value is a +3. So that's my y-coordinate of my vertex. Once I know my axis of symmetry and I know my vertex, and from my equation here this coefficient is negative. So when this coefficient is negative, that means I'm frowning. My parabola will face down. That's enough information for me just to sketch a rough draft of my parabola. Okay, now we're on 25b3. So our equation was y equals -3x squared plus 6x. The fact that this is a negative coefficient in front of my x squared term tells me we're frowning. It's negative, we're frowning. This is an up-down parabola as well. We calculated our axis of symmetry as x equals 1. Again, when you graph the line x equals 1, everything on that line, everywhere on that line, your x value is 1. So you go over 1, that will be a vertical line. All of these axes of symmetry, when it's an up-down parabola, should be parallel to your y-axis. So we're now going to be symmetrical about this dashed line. We're going to draw our axis of symmetry as a dashed line. So that's the line x equals 1. Now we can plot our vertex. Your vertex should be on the axis of symmetry. If your vertex is not on the axis of symmetry, something went wrong. The vertex is the very top or bottom of the parabola, and that should be on the axis of symmetry. And so we're at 1, and then 1, 2, 3. So that is your vertex, and then we said our parabola was facing down, and that's a 3, so that's going to be a narrower parabola. So we will be facing down. So since this is a downward facing parabola, that would be called a maxima point, the very top maximum part of the parabola. Okay, we're doing 25D, 4 through 6. We have this equation, the fact that I have an x squared term and a y where x is squared and y is not, tells me it's a parabola. And when x is squared and y is not, it's an up and down parabola. But I need to put it in general form. General form is y on one side, everything else on the other side, which means I need to subtract my x squared term over here. So I have 2y equals, I can't combine x's and x squared. So I'm going to write my x squared term first, put everything in order. Okay, now I need to divide everything by 2. This is like a 1 right there. So basically I have this negative 1/2 x squared, this negative 1/2 coefficient in front. I'm going to leave it as a fraction because if I go through and try to get rid of fractions, I ended up with a 2 out here. So in some cases, you're just going to have to work with fractions. Okay, so this is my equation. This coefficient in front is a negative, tells me my parabola is going to be facing down. The fact that I have a middle term here tells me it's not symmetrical about the y-axis, that it has been shifted over, so I have to find the axis of symmetry. So to find the axis of symmetry, you use x equals negative b over 2a. You get your b and your a from your equation once you have it in general form. This is your a, b, and your c. So x equals negative, that's the negative sign, then b is a 4 all over 2 times a, and my a is a negative 1/2. Okay, this 2 you can make it into a fraction, putting it over 1. What happens to your 2's? They cancel, and in your denominator you're left with a negative 1. Negative divided by negative is a positive, and 4 divided by 1 is just 4, so basically x equals 4. That is my axis of symmetry, but also that is the x-coordinate of my vertex. So I know that my vertex is going to be at 4 something, and I need to find the y-coordinate. How do I find the y-coordinate? Go back to my equation. I'm going to go back to my general form. Everywhere I have an x, I'm going to put in 4. So, working down here, y equals negative 1/2, 4 squared plus 4 times 4 minus 2. Negative 1/2, 4 squared is 16, I can put that over 1, plus 4 times 4 is 16 minus 2. My 2 and my 16 cancel. Okay, basically this just becomes negative 16 over 2. Okay, negative 16 over 2 is a negative 8 plus 16 minus 2. When you have addition and subtraction left, you do it from left to right. Negative 8 plus 16 is a positive 8, and positive 8 minus 2 is a positive 6. So my y-coordinate is a positive 6. So I can go back up here for my vertex, my y-coordinate would be a positive 6. So now that I have my axis of symmetry, I know my vertex, I know that my parabola is facing down, which tells me that my vertex is a maxima point. It's the very top of the parabola. I have enough information to sketch a rough draft of my parabola. Okay, now we're graphing 25D, 4 through 6. Our equation came out to be y equals negative 1/2 x squared plus 4x minus 2. The fact that x is squared and y is not tells me it's an up and down parabola. I can look at this coefficient. It's negative, which means I'm frowning. We calculated our axis of symmetry to be x equals 4, so you graph the line x equals 4. It means everywhere on that line your x-coordinate will be 4, which tells me it's a vertical line. So you go over 1, 2, 3, 4, and your axis of symmetry will be a dashed line. Then you can plot your vertex. Your vertex should be on the axis of symmetry. So my vertex is at 4, 6, 1, 2, 3, 4, go up 6, 1, 2, 3, 4, 5, 6. That is my vertex. And then we said my parabola is facing down. That is a fraction coefficient, which tells me it will be a little bit wider parabola. So I'm going to make this a little wider. And it's just a rough sketch. I'm not plotting any extra points. This is all I'm plotting. Remember, your vertex should be on the axis of symmetry. Okay, we're looking at 25b6. So when y is squared and x is not, that tells me it's it tells me it's a right-left parabola. I believe that this might be the only right-left parabola in this lesson, but I'm not 100% guaranteed. But anyway, so I'm going to do a right-left parabola for you just as an example. It's already in the form to where x is on one side and everything else is on the other side. I basically have this plus 0 out here, which I have a middle term, and since I have a middle term, it tells me I'm not symmetrical about the x-axis, that it's been shifted. So I've got to find the axis of symmetry. When we're dealing with right-left parabolas, our formula is y equals negative b over 2a. We're using the variable that's over here. So I'm figuring out the y-coordinate of the vertex. When you have right-left parabolas, you don't call the vertex a maxima or minima. You only call the vertex a maxima or minima when you have up and down parabolas. So now I need to find the y-coordinate of the vertex. And again, this is still my a, b, and my c values from the coefficients. So putting that into the formula, y equals a negative, and then my b is 8, all over 2 times a, which is 2. So negative 8 over 4, which is a negative 2. So my axis of symmetry is y equals negative 2, but that is also the y-coordinate of my vertex. When you're writing this, your coordinates of your vertex, make sure you put your negative 2 in the y position. Remember, coordinates are x and then y. So that is my y value of the coordinate. So in order to find my x value of the coordinate, then I take this value and go plug it in everywhere that I see a y to determine my x value. So x equals 2, and then my y was negative 2 squared plus 8 times negative 2. Negative 2 parentheses squared is a positive 4, and a positive 4 times 2 is 8, plus 8 times 2, positive times a negative 2, not 8 times a negative 2, would be a negative 16. So 8 minus 16 is a negative 8. So that is my x coordinate for my vertex. So now that I know my axis of symmetry and my vertex, and looking at my equation, this coefficient in front is a positive, which means it will face to the right. So I have all the information I need to be able to sketch a rough draft of my, or a rough sketch of my graph. Alright, now we're graphing 25b6. X equals 2y squared plus 8y. The fact that y is squared and x is not tells me it's a right-left parabola. So looking at this coefficient, it's positive, which tells me it will face to the right. We calculate our axis of symmetry as y equals negative 2. Now remember, everywhere, how do you graph the line y equals negative 2? Everywhere on that line, your y value will be negative 2. This will be a horizontal line. So go down, y equals negative 2, and that will be your axis of symmetry. We still draw it as a dashed line. Okay, so now you plot your vertex, and your vertex should be on the axis of symmetry. Negative 8, negative 2. Going in the negative 8 direction of x. 1, 2, 3, 4, 5, 6, 7, 8, and then down 2. There's my vertex right there. And then from the equation, that coefficient's positive, which we said is facing to the right. It's a 2, so it's going to be a narrower parabola. So I'm just doing a rough sketch of what it's going to look something like this. So this is how you would do it when you have a right-left parabola. Okay, now we're looking at this word problem. This is an application of where maxima and minima are used. That everything that we just learned actually has an application in the real world with word problems. So the first thing that I'm always going to tell you is to draw a picture. These will truly help if you draw a picture. So Mike needs a fenced play area connected to the house. He has 200 feet of fencing for the rectangular space. What are the dimensions of the largest possible yard? I've underlined some very important words. First off, this play area is connected to the house and it's going to be a rectangular space. So if we drew a picture like this, let's just say that this is his house, and then he wants a rectangular play area. Okay, so the house is not included in the fencing. Okay, actually maybe I should draw the fencing in a different color. Only the fencing is the 200 feet. This purple line represents the 200 feet that we're going to use for fencing. So we want to know what are the dimensions of the largest possible area. The fact that we're using the word largest means the maximum. So this is where this comes into play. When we were doing these equations, when we found the vertex, we were finding the maximum or the minimum value of that parabola. So if we can get an equation in the form of a parabola, then we can find the maximum or minimum value using the axis of symmetry equation. Okay, so the important first thing is draw a picture. We're connected to a house. We know it's a rectangular space. So now we know we have 200 feet of fencing. So remember, perimeter means you add up all these areas. So this side plus this side plus this side is going to equal 200. Well, we don't know what they are, so we have to start assigning some variables. Okay, so let's just say we assign that as a variable x. Well, if it's rectangular, then we know that this also has the same dimension. Okay, so now we know that this plus this equals 200. So we know that, so we could say, y'all follow me, 200 minus 2x. Because this side is going to equal the 200 feet minus adding these two sides. This side has to be the 200 feet of fencing that we had, subtracting off these two sides. Because now if you take this plus this, that will equal 200. See, x plus 200 minus 2x will equal 200. Because x plus x is 2x, 2x minus 2x, those all cancel, and that equals 200. So that's where this comes from. I took the 200 minus adding these two sides together. That would be the length of this side. Now, how do we find the largest possible? We want to be able to make the largest possible area. It didn't say area in there, but in order to find the dimensions, we need the largest possible area. How do we find the area of a rectangle? Base times height. Okay, so the area of my rectangle is base times height. Okay, my height is x, this is my base. So for the maximum area, that equals my 200 minus 2x times my height. So now let's distribute that. So that would be 200x minus 2x squared. Alright, that's my maximum area. Do you see that it's starting to look like the equation of a parabola? Let me put it in this form to show you. Negative 2x squared plus 200x, and then there's nothing out here, plus 0. Okay, this is our maximum area. We can use y if we want to represent the maximum area. And then this looks like the equation of a parabola. It's important to put it in this order, to put it in general form of your x squared term first and then your x term, because now in order to find the maximum value of x, the maximum value of any parabola, this would be facing down, so it would be a parabola like that. That maximum value is at the top, which is the vertex. That x coordinate will tell me the maximum value. So we can use our formula of x equals negative b over 2a, which tells me the x coordinate of the maximum value. So when you're finding the maximum value, you can use this formula. So plugging in our numbers, so this was our A, B, C. So negative B, negative, and then B is 200, all over 2 times A, and A is a negative 2. So that would be negative 200 all over negative 4. A negative divided by negative is a positive. That's good. When you're dealing with dimensions and you're dealing with real world stuff, especially in dimensions, you should get a positive number. If you get a negative number in dimensions, you've done something wrong. So 200 divided by 4 is 50. And when we found a maximum area, these were all in feet. That was feet, feet. And so our maximum area, this was really square feet. So when I found my value of x, this is going to tell me the number of feet. Now, what did this represent? If you go back to your picture, it will help you. Going back to your picture, we said x is going to represent that dimension right there. So now I know to get the maximum area of a play yard, this dimension needs to be 50 feet. So if I know this dimension, I know what x is, I can figure out this dimension. Because this dimension will be 200 minus 2 times 50. I'm just plugging in. We said x is 50. So that would be 200. 2 times 50 is 100. So that dimension would be 100 feet. So to get the maximum play area, our dimensions need to be 50 feet by 100 feet. That would give us the maximum possible, the largest possible play area for the yard.